Hello students, myself Kasale, Junior College Teacher, Department of Mathematics from RED Shikshan Samstha's RBNB College, Srirampur. Students, in the last lecture we have seen function and types of functions. Now today we are going to study some basic functions and definitions of that some basic functions. Now some first basic function is constant function. Constant function. Now we have to see a definition of constant function, then examples for constant function and range and domain for the constant function. A function f of x is defined by f of x is equal to k, where k is constant, is called as constant function, For example, f of x equal to 2. Second example, f of x is equal to 7, f of x equal to 9, f of x equal to 20. All these are constant functions. Okay. Domain for the constant function is set of real number, and range of constant function is k. Range is set of constant function, that is k. Okay. Now we can draw a graph for this constant function. Graph for function f of x is equal to 3. F of x is equal to 3. That is, we can draw here coordinate system. This is origin, x-axis, y-axis, and we can take scale on axis 1, 2, 3, and so on. Here also 1, 2, 3. Okay. Now here also minus 1, minus 2, minus 1, minus 2, so on. Now we have to draw the graph for this function f of x is equal to 3, and graph for this function is straight line parallel to the x-axis. Okay, f of x is equal to 3. We can draw the graph for any constant function this way. Okay. Now second function, basic function is identity function. Definition for this: a function f is defined as or defined by f of x is equal to x, or I on x is equal to x for all values of x. For all values of x is called as identity function. Okay. Now domain and range for this function is domain and range. Domain is equal to R, set of real number, and range of function, identity function, is also R, set of real number, or domain equal to range is equal to open interval minus infinity to infinity. This is the domain and range for the identity function. Okay. Now we can also draw a graph for identity function. Graph for identity function, any function, you can take again coordinate system like this, y-axis, x-axis, y dash, x dash. This is the origin O, and graph for any identity function is a straight line passing through the origin. Okay, this is the graph for f of x is equal to x, y is equal to f of x is equal to x. Okay, this is the identity function. Now next function is power function. Number third, power function. Power function. A function f is of the form y is equal to f of x, or f of x is equal to a into x raised to n, a into x raised to n, where n is any real number or any natural number. N is natural number and this function is called as power function. Now in power function there are two types. Number first is the square function and second is cube function. Number first, square function. A function f is defined as f of x equal to x square. F of x is equal to x square is called as a square function. Is called as a square function. Now range for the square function and domain for the function. Domain for the square function first. Domain is set of real number, and range of the square function. Range of the square function is equal to closed interval 0 to infinity. 0 to infinity. Okay. We can also draw the graph for this square function. Function is f of x equal to x square, that is y is equal to f of x is equal to x square. Now graph for this function. Graph for square function. Graph for square function is this is the x-axis, origin xo x dash, yo y dash, coordinate system. Now we can take scale. On x-axis 1, 2, 3, 4. On y-axis 2, 4, 6, 8, 10 and so on. Now graph for this function y is equal to x square is a parabola like this. This is the graph for the function y equal to f of x equal to x square for the square function. F of x is equal to x square. This is the equation for this curve. Okay. Now in power function, second function is cube function. Second is cube function. A function f of x is defined as or defined by f of x is equal to x cube is called as cube function. Is called as cube function. And here domain and range for this function, cube function, is same, that is domain equal to range is equal to r, or open interval minus infinity to infinity. This is the domain and range for the cube function. Okay, now we can also draw a graph for the cube function. We can draw here graph for the cube function, graph for f of x is equal to x cube. Again we consider coordinate system here. X O x dash, y O y dash, and we can draw graph for this cubic function f of x equal to x cube like this. F of x is equal to x cube. We can take scale on the x-axis and y-axis also, and graph for the function cube function f of x equal to x cube. We can draw this pattern. Okay, now next function is polynomial function. Number 4, polynomial function. Definition for this polynomial function: a function f is defined by f of x is equal to a0 into x raised to n plus a1 into x raised to n minus 1 plus a2 into x raised to n minus 2 plus so on an into x raised to 0, where n is non-negative integer. N is non-negative integer, and a0, a1, a2, so on an are the real numbers. Are real numbers is called as polynomial function. Polynomial function. Okay. Now you can see examples for polynomial function like this: f of x is equal to x cube plus 5x square minus 2x plus 3. This is the polynomial function. Second example is f of x is equal to again x square minus 6x plus 7. This is also polynomial function. Okay. Now in a polynomial function there are three types. Number first is linear function. Linear function. Definition for linear function: a function or any function f of x of the form f of x is equal to ax plus b is called as linear function. For example, f of x is equal to 2x plus 1 f of x is equal to 2x plus 1. This is the linear function. Okay. Now domain and range for this linear function is again same. Domain equal to range equal to R or set of numbers from minus infinity to infinity in open interval. This is the domain and range for the linear function. We can draw a graph for this linear function f of x equal to 2x plus 1. Graph for f of x is equal to 2x plus 1. Okay. Now here also we can draw coordinate system again. X O x dash, y O y dash. You can take scale on x axis, y axis also. And 1, 2, 3, so on. Here also 1, 2, 3. And graph for this function, linear function f of x equal to 2x plus 1 is like this. F of x is equal to 2x plus 1. Okay, this is the graph for linear function. Now in polynomial function, second function is quadratic function. Second function is quadratic function. Number second, quadratic function. A definition for quadratic function: any function of the form, any function of the form f of x equal to ax square plus bx plus c. F of x equal to ax square plus bx plus c, where a is not equal to 0, is called as quadratic function. Quadratic function. Now examples for quadratic function. Example: y is equal to f of x is equal to 3x square plus 4x plus 5. This is the quadratic function. Okay. Now here domain for the quadratic function is R and codomain is set of numbers k to infinity. Domain for the quadratic function is R or minus infinity to infinity, and range for this quadratic function is k to infinity, open interval, semi-open or semi-closed interval. Now third polynomial function is cubic function. Cubic function. Any function of the form f of x equal to ax cube plus bx square plus cx plus d, where a is not equal to 0, is called as cubic function. Cubic function. Now here domain and range for the cubic function is also same, that is set of real numbers or open interval minus infinity to infinity. Domain is equal to range is equal to R or set of minus infinity to infinity in open interval. Okay, this is the domain and range for the cubic function. Now next is radical function. Number 5, basic function, radical function. Of function f of x is defined by f of x is equal to a into nth root of x, where n belongs to n is called as radical function. In a radical function also there are two types. Number first is square root function and second is cube root function. Now first function here, square root function. Any function of the form f of x is equal to under root x for all values of x, is called as square root function. Okay, this is the square root function. We can draw a graph for this square root function also, and domain and range for this function is again same. First way, say here domain is equal to range is equal to open interval 0 to infinity. This is the domain and range for the square root function. Graph for the square root function. The graph for function y is equal to f of x is equal to under root x is. Now here we can draw coordinate system again. x o x dash x axis, y o y dash y axis. We can take scale on the axis, x axis 1 2 3 4 here also 1 2 3 4 here -1 -2 -1 -2, and graph for this square root function we can draw like this. This is the graph for the function y is equal to f of x is equal to square root of x. Okay, now next function is second type in radical function. Number second, cube root of function. Now definition for cube root of function. A function f of x is defined by f of x is equal to cube root of x is called as cube root function. The functions which are of the form f of x is equal to cube root of x is called as cube root function. Okay. Now graph for this cube root function can be drawn in the form graph for the function. Graph for y is equal to f of x is equal to cube root of x is, we can draw here again coordinate system, y-axis, x-axis, xo x dash, yo y dash, scale on x-axis 1, 2, 3, 4, on negative x-axis minus 1, minus 2, minus 3, 1, 2, 3, 4, here also minus 1, minus 2, minus 3, and we can draw a graph for this function like this. This is the graph for cube root of function, that is equation for this curve y is equal to f of x is equal to cube root of x. Okay, this is the graph for cube root of function. Now next basic function is number 6, rational function. Rational function. Now before that, range of this cube root of function is again same, that is domain. Domain is equal to range is equal to R, or set of numbers from minus infinity to infinity in open interval. Now definition of rational function. A function of the form of the form f of x upon g of x, where f of x and g of x are polynomials and g of x is not equal to 0. G of x is not equal to 0 is called as rational function. This is the definition for rational function. We can say examples for rational function. F of x is equal to, first example for rational function, f of x is equal to 1 upon x for the interval r minus 0. R means set of real number except 0, values of x are in set of real number. Is a rational function, f of x equal to 1 upon x. Second function is again f of x equal to x plus 2 upon x square minus 1. This is also a rational function for interval r minus 1, 1. Is also a rational function. We cannot take here values of x are minus 1 and 1 because this denominator becomes 0. Okay, this is the basic function, rational function. Now number 7 function is exponential function. Exponential function. Definition: a function of the form f of x is equal to a raised to x or f of x is equal to e raised to x, where a is greater than 0, where a is greater than 0 is called as exponential function. For examples, number first, f of x is equal to 3 raised to x. Number second, f of x is equal to e raised to x, f of x is equal to 5 raised to x. All these are the exponential functions. Okay, domain of this exponential function is set of real number and range is open interval 0 to infinity. Domain is equal to set of real number and range of the exponential function is open interval from 0 to infinity. Okay, this is the exponential function. Now last basic function is logarithmic function. Logarithmic function. So first we see definition for logarithmic function. If x is equal to a raised to y, where a is not equal to 0 and a is greater than 0, a is not equal to 1, then a logarithmic function y is a logarithmic function to the base e, and it is written as log y, y is equal to y is a logarithmic to the base a, logarithmic function to the base a, and it is written as y is equal to log x to the base a. Y is equal to log x to the base a. This is the logarithmic function, and if we write this x is equal to a raised to y, then this is the exponential function and this is logarithmic function. Now we see some properties for logarithmic function. Properties for logarithmic function. First property is, if as a raised to 0 equal to 1, as a raised to 0 is equal to 1, then by definition of logarithm here, a raised to y equal to x, then y is equal to log x to the base a. Therefore, as a raised to 0 equal to 1, then we can write here log 1 to the base a is equal to 0. That is, value of log 1 to the base a is equal to 0, and as a raised to 1 is equal to a, then again by definition of logarithm, log a to the base a is equal to 1. Log a to the base a is equal to 1. This is the first property. Now second property is, as a raised to x is equal to a raised to y, if and only if x is equal to y. A raised to x is equal to a raised to y if and only if we get x is equal to y. And again we can consider logarithmic form here. Log x to the base a, log x to the base a is equal to log y to the base a if and only if again x is equal to y. X is equal to y. This is the second property. Now third property for logarithm. We consider any three numbers a, b, c greater than 0. Now this is called as product law for logarithm. Third property is product law of logarithm. If a comma b comma c greater than 0, then log of b into c to the base a, product of function numbers b into c to the base a is equal to log b to the base a plus log c to the base a. Okay, this is the product rule of logarithm or product law of logarithm. We can again explain this law by considering three numbers b, c, d. Log of b, c, d to the base a is equal to, we can write here, log b to the base a plus log c to the base a plus log d to the base a. We can extend this law like this: log of b, c, d to the base a is equal to log b to the base a plus log c to the base a plus log d to the base a. This is the product law. Number 4th, quotient law or division. Division rule of logarithm. Division rule of logarithm. Here also we can consider any three numbers a, b, c greater than 0. A, B, C greater than 0 and A is not equal to 1. A is not equal to 1. Here also we can take A is not equal to 1. Then here division rule is log of B upon C to the base A is equal to log b to the base a minus log c to the base a. This is the division rule of logarithm. Now number 5th rule is power or exponent rule. Power or exponent rule. Here also we consider any three numbers a, b, c greater than 0. Now 5th rule is consider three numbers a, b, c greater than 0 where a is not equal to 1. Then power or exponent rule is log of b raised to c to the base a is equal to c into log b to the base a. This is the exponent rule or power rule for the logarithm. Now number 6 is change of base rule. Number 6, change of base rule of logarithm. Now here also we consider three numbers a, b, c greater than 0, a is not equal to 1. Then we can write here log of b to the base c is equal to log of b to the base a upon log of c to the base a. This is called as change of base rule for logarithm. Okay. Now also we know that e is a natural base for the logarithm. That is number 7. For natural base, for natural base e, we can write here log of x to the base e is equal to log of x. We can write only simply log x, then there is a base e, okay, which is called as natural base for the logarithm. Okay, today we stop here. Thank you.